welcome to the presentation of this mini project 3. In this project we demonstrate the CNN approach applied on the DDoS attack detection on the image dataset which we get from the IEEE data port. And in this presentation I will only show running part of the project and some logic parts as well. So let's start by examining the cell 0. In this cell, we determined the seed number for global seed for making our results reproducible, and also other library imports as well as other cells importing other libraries when they are required. And also in this cell, we import the dataset which we put inside our drive, and then some hyperparameter settings like dropout for reducing overfitting and increasing regularization, and also some other weight decay for optimizer and regularization, some other hyperparameters. Also we define the image size and batch size for making our training much more efficient, and also some other TensorFlow functionalities, and also for training stages, number of epochs and fine-tuning epochs, we also show that. And for the fine-tuning too, some other learning rates and so on, other kind of hyperparameters. And in here, also we are dividing it for the train, val, and test set in order to train and validate and also test our model. And these are some other conventions according to image data to make it process efficient. And these are the results. It's successfully created our results. And this cell 3 is for indexing data to data frames, label mapping, split counts, and also class weighting, prior trading, and class name corrections. As we can see, it first splits the data we get, then it uses some label filtering because we find out that there is some limitations in the dataset. It actually have 13 classes, but 3 classes are conflict with each other. We tested data leakage from image similarity and so on, and our finding is these 3 classes is very similar to each other, and there should be any conflict when they are creating this dataset. So we filter them because after some binary search and so on, we find out that filtering these 3 classes and working with only 10 remaining classes is much more efficient for developing CNN approach. And let's run this cell also to show it is working correctly. As you can see, train, test, and validation sample numbers and so on. Also some other weight numbers for each class for prioritizing. And this cell 4 is TF data pipeline using TensorFlow library and quick batch visualization and step prepper. It's both processing the data and giving some visualization about how our dataset looks like. As we can see, it's done some NumPy operation as well for batching our image dataset. So let's run it to prove that it is working correctly. As you can see, it starts working and give us some output, but still running because image datasets usually takes longer to finish. So we are waiting. And while this one running, let's examine this one. The model components, augmentation, and gem pooling. Well, what is gem pooling? Gem pooling is generalized mean pooling, and abbreviation is GAM. Why we are using them instead of some traditional average pooling or max pooling? Because It is a smooth compromise between average and max pooling, often giving better representation of the pooling algorithms. This one's still running. And also, it's better to adopt pooling behavior, focus on strong activations, being as brittle as pure max. And this has increased our performance up to 5% after our experiments, so we use that. Also, we use ConNet Next T model as transfer learning because after trying several different models, this model give the best of our results. So I will show this model, and this is the end of this function call. As you can see, some sample batch from our dataset, the images of each DDoS attack with their representative look. So let's run this one also, and it runs. So let's build a model, which our model consists of the connex tiny model for transfer learning, gem pooling for better optimization and regularization and getting better F1 score, and also dense dropout head for better regularization and better performance. So let's build our model. And this is the general look of our model. A number of params and batch normalization, other batch normalization layer. We took 2 batch normalization for better normalize our model, dense prediction, and so on. This is the general shape of our models, total params, trainable params, and all of them are listed in here. Also some details about the gem pooling and so on. And this is the running, training, and testing fully evaluated cell. So let's run it. And after that, let's run this one to see it is running. This will run our training set according to some optimizations like frozen backbone and some other forms of performance optimizations according to macro F1 because F1 is our priority model comparison metric because we are evaluating by the F1. So let's wait to see it is running. I will only wait until the first epoch starting to see. Because of this algorithm takes more than 1 hour to finish, I will not wait until it finish. I will show just it is running. And let's continue because this one took about 1 hour. And after this fine-tuning one, we are doing second fine-tuning. And for better optimization and better scores. And this is our results of the second fine-tuning according to parameters and other settings we have done. It took about somewhere around 17 epoch to finish, and this is our validation results and also test results after temperature scaling. Our macro F1, some uniform and temperature scaling also improve our F1 0.3%. As we can see, raw prediction with temperature, prior and uniform and prior uniform temperature. These are results and they increased significantly. And also by F1 and by loss, 2 different learning. It will make punishment to our training according to loss, and this one make punishment according to F1. And this is our results according to this one. And also this one, the top 3 CM courses and F1 by class. These are some results and also some accuracy table metrics, graphics, and some other confusion matrices. Also we mentioned them in our research paper. And some other saving and CSV file for making ensemble learning later. Giray will explain them. And some rock curve proteins and so on. And this is the presentation of this project. As you can see, it's only finished one epo until now. So we are not wait until it finish, but it is working as you can see. It start the second epo. And that's it for this presentation. This is our research done. Thank you for listening.